Hello and welcome to the tutorial on finding the equation of a straight line. This follows on directly from a tutorial on finding the gradient of a line. If you haven't watched that one already, please, I'd suggest you go back and have a look at that one briefly before we start. As always, if you could copy down the information regarding the actual rules that we're introducing in this tutorial into your workbooks. And the problem we're going to solve this time gives us 2 points. The first and our second point, and asks us to find the equation of the line between that. As you can see in this formula, we need to have the gradient and one other point. So our first step, I guess, with this particular one is actually to find the gradient of the line. So we'll start there. So using the formula that we looked at in the previous tutorial, we can find the gradient. And before we start, let's identify our left point as x1, y1 and our right point as x2, y2. So looking at those, y2 has a value of 2 and y1 6. x2 has a value of 5 and x1 has a value of 3. So that gives us negative 4 over 2, or a gradient of negative 2, which isn't surprising because our line is heading downhill relatively steeply. Okay, moving along now, we'll use our new formula to help us determine the equation of the line. So as always, writing the formula out prior to using it. And it doesn't matter which of our points we use, whether we use x1, y1 or x2, y2, but just to avoid confusion, I'll use these values here where y1 has the value of 6, the gradient is the one we've just calculated, and x1 has a value of 3. So expanding the brackets there, we find that y takes 6 equals negative 2x plus 6. We've got this negative 6 here, so we want to take it over to the right hand side, and of course we do that by adding. So therefore we will add that 6 from the left hand side, and that gives us our final equation of y equals negative 2x plus 12, which we can mark in on our line here, and we can also add in the y-intercept of 12, and that's complete.